My name is Ben Holmes, and I'll be presenting SEVeriFast, which is joint work from Vassar College and Virginia Tech. Today's major cloud providers, like Amazon, Google, and Microsoft, all offer confidential virtual machines, or VMs, where VM memory is encrypted to protect user data. However, there are no confidential offerings for serverless. Serverless applications are partitioned into functions, or lambdas, which are isolated and ephemeral units of execution. When a lambda runs, a new VM boots, incurring additional latency, also known as a cold start. AWS has developed microVMs, which boot in tens of milliseconds to reduce this cost. In our work, we answer the question, how can we boot confidential VMs while maintaining microVM comparable cold starts? In a confidential setting, the host is completely untrusted, and we can't rely on it to set up our VM. Instead, the virtual machine monitor, or VMM, asks a trusted hardware module to measure the initial contents of VM memory by computing a hash. The hardware module stores this hash, which will later be signed and sent to a trusted third party to verify that the VM was set up correctly. This hash establishes trust for the VM and is integral to security. We found that when the initial boot code and data are typical microVM components, computing this hash and hardware is very expensive, on the order of seconds. To address this, we propose SEVeriFast, a novel bootstrap scheme that minimizes the root of trust for fast boot by moving the majority of measurement to software. MicroVM monitors skip bootstrap stages like a BIOS, boot an uncompressed kernel to skip decompression, and pre-initialize guest state. Our work comes to the counterintuitive conclusion that adding an additional bootstrap stage, booting a compressed kernel, and selectively pre-initializing guest state allows us to minimize the root of trust and reduce confidential VM boot times over the state-of-the-art by 86 to 93%.